Hello, today we're going to talk about surface area. So the first thing that we're going to talk about is solids with plane faces. So when we say plane, we mean flat. So it is a flat surface, meaning that when we sit it down somewhere, it's not going to roll. Anytime we find the solid of a plane, we deal with solids with plane faces, we know that the surface area of that 3D figure is going to be just the sum of all of the areas of the faces. So basically, I literally have to look at the shape of each face that the solid can sit on, and I want to find the area of each of those faces and then add them up together. So let's look at example one. It says, find the surface area of the pyramid below. As you can see here, in this pyramid, we have five faces. We have the triangles that are going around the sides. There are four of them, one in the front, one in the back, one on the left, one on the right. And then we also have our base or our bottom face, which is a square. And I know it's a square because I have 90-degree angles and they both have the same length and the width. So I have to find the area of all of those shapes. So let's start with the triangle. So in order for me to find the area of my triangle, and let me make sure I highlight the triangle here. So in order to find the area of this triangle here, one thing that I do know that I need to have is I need to know the height of this triangle. All right, so I need to know the height. Well, one thing about it is when I drew in that height here of this triangle, that ends up making a 90-degree triangle when it comes to the height of the pyramid, which starts at the apex or the top, and it goes to the center of the square. That's going to form a right triangle there, or a right triangle. So we already know that the height of the pyramid, once again, goes from the top of the pyramid down to the middle of the square base. Then we have the hypotenuse, or the height of the triangle face, is going to be labeled H. So we know that the height of the pyramid is 4. We do not know the height of the triangular face, and we do know that the length of the square is going to be 9. Well, since the length of this square is 9, then that means that if I go halfway, then that means that the length of that right triangle that I made is 4.5, because it's half of 9, because I'm going from the edge of the square to the middle of the square, which is halfway. So now that I have this, I can use the Pythagorean theorem to find what the height of the triangle is. Remember, the height of the pyramid is not the same as the height of that triangular face. So if we were to use Pythagorean theorem, we will have 4 squared plus 4.5 squared is equal to c squared, or h squared. And then I would literally type it into the calculator. That's going to be 4 squared plus 4.5 squared. That is going to give us 36.25 is equal to h squared. And then I'm going to take the square root of 36.25, because I have to take the square root of both sides. And I end up getting 6.02 is approximately the height of that triangular face. Now I'm using the approximate symbol because I'm not using the exact number in the calculator, which is that long 6.02079728.9. I'm not using that whole unrounded number, so I'm going to use the approximation symbol. So now that I have that the height of that triangle is 6.02, I'm going to write it in, and then I'm going to finish calculating my surface areas. So now that I know what my height of that triangle is, I can actually find the area of it. So the area of a triangle is 1/2 times your base times your height. So I'm going to have, remember, revert back to the original triangular face. that green part. If I do 1/2 base times height, that is going to be 1/2 times 9, because that's the base length of the triangle, times the height of the triangle, which is 6.02. And once again, I'm going to use the approximation symbol because I know that that 6.02 is not exact. It is rounded. So I'm going to type that in. 1/2 times 9 times 6.02. And I end up getting that our area is approximately 27.1 in 3 significant figures. And then we have the area of the square, which is equal to 9 times 9, which is going to be 81. All right. So then we literally find our surface area of the total pyramid, and that is going to be equal to the area of the square plus 4 times the area of the triangle, because we have 4 triangles. Okay, we have 4 of those triangles. So now I put in 81 plus 4 times 27.1, and we end up getting in 3 significant figures 189. And of course, we have to put our units, and we're talking about area. So this is going to be inches squared. All right, so that is our surface area of that pyramid. So now let's talk about areas with curved surface in the formulas. So here we have a cone, a sphere, and a cylinder. So the following formulas for the surface areas are as follows. When you have the cone, we have that the surface area is equal to pi times r times L. L is our slant height. Okay, L is the slant height. That's the height that's leaning. That's why we call it an L, leaning L. Okay, so we have to do pi times the radius times the slant height, which is the L here. So pi times r times L. And then you have to add it to the area of that circular base, which is pi r squared. All right, therefore we can say that pi r L is the area of the curved surface, and then pi r squared is the area of the base, which is a circle. Okay, the formula for the surface area of a sphere is just 4 times pi times r squared. And then the surface area of a cylinder is equal to pi r h plus 2 pi r squared. So we already know that the 2 pi r squared, we already know that part comes from being the area of both of the circles on the top and the bottom. Okay, so it's the area of 2 circle bases. All right, now let's talk about what the 2 pi r h represents. So think about this. If you have a can of vegetables out of the store and you want to take the wrapper off without messing it up, you will cut it straight up and down and you will roll it flat out. What you need to realize is that this height, the height of the can, is going to be the same thing as the height of the wrapper. And then you will need to realize that the circle around the can, okay, is going to come from wrapping the paper around it. So it's the length of the top here. So the perimeter of a circle, or the length of that circle, is 2 pi r. That's the circumference, which means that the length of, or the width of that wrapper is also going to be 2 pi r. So that's why we have 2 pi r times h, because we have length times width, and 2 pi r is the width or the length, and h is the width. So we know that 2 pi RH, once again, is going to be the area of the curved surface, but we already know it's going to be the curved surface of the cylinder. All right, so that is what our formulas are. All right, so let's start looking at some examples here. So let's look at example number 2. So it says, find the surface areas of the figures below. Okay, so if we look at A, that is a cone. And we know that the surface area of a cone is A is equal to pi r L plus pi r squared. So one thing that we should see here is that we do not know what the radius is. So I'm going to draw that radius in, and then I'm going to try to find the radius. Well, notice, when I drew that radius in, I made myself a right triangle, which means that I should be able to use the Pythagorean theorem. And we know that that is a squared plus b squared is equal to c squared, making sure that we know that the c is the hypotenuse, which is across from the 90-degree angle, which means that our c will be 41.9. So what we're going to do is we're going to set up that equation, and that equation will be r squared plus 37.2 squared is equal to 41.9 squared. 41.9 is the hypotenuse, and 37.2 is the leg, as well as r is the other leg. So I would have to subtract 41.9 squared and 37.2 squared. I'm going to subtract 37.2 squared on both sides. And then I'm going to have to take the square root of that result, which would end up giving me 19.28. So here I will know that r squared was equal to 371.77. And then we take the square root, and we get that r is approximately 19.3 if we write it in 3 sig fig. All right, so now that we have our r, I'm going to write that in. So that is 19.3. All right, so now we can use our formula. So if we go back to our formula, we know that the surface area is going to be equal to pi times the radius, which is 19.3, times the slant height, which is 41.9, plus pi times r squared, which is 19.3 squared. And once again, because we are using the 19.3, the rounded version and not the full version, we're going to use the approximate symbol. And see, once I do that, I just literally put it into my calculator. Pi times 19.3 times 41.9 plus pi times 19.3 squared. So we end up getting that our surface area is approximately 3,710 in 3 sig fig, and we know that our units is going to be centimeters squared. All right, so that's our surface area. So now let's look at the surface area of the sphere. So the formula for the surface area of a sphere is the surface area is equal to 4 pi r squared. All right, so all I have to do is figure out what my radius is. If my diameter is 27 feet, then that means the radius is half of that. So I'll do 27 divided by 2. And here I will see that my radius is equal to 13.5. All right, so when I substitute into my formula, I'm going to have that the surface area is equal to 4 times pi times 13.5 squared. All right, and I literally typed that into the calculator. 4 times pi times 13.5 squared. So when we do that, we will end up getting that our surface area is approximately 2,290 feet squared. Remember, we're talking about area. And remember, surface area. All right. So now, if we look at C, it says we want to find the area of this cylinder, but they did let us know some information. They said that we have what they call a hollow base. The word hollow means empty or open, meaning that it's not there, meaning that it's not going to be covered or included in the calculation. So one of these bases is hollow, meaning that we're not going to include the surface area of it. So remember, the surface area formula for a cylinder is going to be that the surface area is equal to 2 pi r times h plus, we don't have 2 pi r squared anymore because we don't have two circles if it's hollow. They said one of the bases is hollow, so we're only going to have one circle here. So this is just going to be pi r squared because we're not going to include one of the circles because it is hollow. So I'm just going to mark an X here so we can know that we're not including it because it's open. So all we have to do is substitute everything that we know. Well, once again, we know we have the radius, but they gave us the diameter here. So I know that the radius is going to be equal to 21 because it's half of 42. So now that I know that my radius is 21, what I'm going to do is I'm going to plug it into my formula. So we're going to end up having that the area or the surface area of the cylinder is going to be equal to 2 times pi times the radius, which is 21, times the height of the cylinder, which is 7.5. Now, do not think the height is going to be the 42. The 42 is talking about the diameter of the circle. When we talk about a cylinder's height, we normally sit it on the flat side. So it's kind of like you would turn that can. You would turn that, if you imagine it as a can on the side, you need to turn it right side up. And then we will have to add pi times r squared. So if we substitute and plug that in into the calculator, be careful what you type in to make sure you're doing it accurately. When we put that in the calculator, we end up getting that our surface area is approximately 2,380 inches squared in 3C feet. All right, so that is our surface area here. So now let's look at example 3. It says that we have a length of a hollow pipe. So let's say if I have a pipe here. All right, so if I have myself a hollow pipe, that means that because they said hollow pipe, they didn't say hollow end. That means that both ends are open. So it's like having an empty roll of toilet tissue and it's completely empty and it's open on both sides. So one thing that we do know is that we know if we were to draw this pipe, our radius would be here. So if our radius is here, we have to then label based off of the word prompt. So it says that the length of the hollow pipe is 3/2 of its radius. So if I know that my radius is r, then I know that the length is going to be 3/2 times that length of that radius. So I'm just going to label it. So now it says write an expression for the outer surface area in terms of the radius. The outer surface area is referring to the curved surface area. All right. And we know that the curved surface area of a cylinder is given to you by, and I'm going to put area of the outer. We know that that curved surface area for a cylinder is the portion that is 2 pi r h. So if I substitute that information in, I'm going to have 2 times pi times r and times the height of the cylinder, or the length of it, which will be 3/2 times r. So if I were to simplify that, 2 times 3/2 is 3. The pi would be multiplied, and then r times r is r squared. So we will end up getting that it will be simplified to 3 pi r squared. That will be the expression for the outer surface area of the cylinder. So now they then ask us as a follow-up, if the curved outer surface is 285.1 feet squared, find the diameter of the pipe. So they gave us the outer area, so we're going to have 285.1, and we're going to have that equal to 3 pi r squared. I'm going to solve that equation. So I'm going to divide both sides by 3 pi. Make sure that if you're going to do this, you use the fractions in the calculator, the pretty fraction alpha y equals, or you either put parentheses around the 3 pi when you divide by it. All right, so when we divide by 3 pi on both sides, we end up getting 30.3 and 3 sig fig, and I know that's rounded, so I'm going to use approximate, and then that's going to be equal to r squared. So then I'll take the square root of both sides, and the square root of 30.3 is going to give me 5.50 in 3 sig fig. So that is my radius. And then one thing that we do know about the diameter is we should know that your diameter is equal to 2 times your radius. And if I know that my radius is 5.5, I'm going to have 2 times 5.5. And let me use the approximate symbol here, because remember 5.5 was not 5.5 exactly. Then we know that our diameter is approximately 11, and our units is going to be feet, because we're talking about the length. It's not feet squared. We're not talking about area. We're finding the length of the diameter. So if you have any questions about surface area, please let your teacher know, and have a great day.